Okay, so our final assignment in unit number 8, we're actually going to be graphing radical functions. You've done a little bit of this in Algebra 1, but we're going to really extend this idea so you can graph not only square root equations, but cube root equations. And so let's go ahead and get started with this. So graphing square roots, we're going to start with a parent function, just y equals the square root of x. And we have a table of values. X could be -1, 0, 1, 4, and if we take the square root of -1, we know that's an imaginary number. We take the square root of 0, we get 0, the square root of 1 is 1, the square root of 4 is 2. If we start plotting those points on a graph, then this is what we'll have. We'll have a point 0, 0. We're going to have a point at 1, 1. We're going to have a point at 4, 2. And if we smooth this out and graph all of the points, it looks like this. It actually starts at the point 0, 0. Goes to the point 1, 1, the point 4, 2. It also goes through the point 9, 3, and so on. But we can't take the square root of a negative number, so we can't use any of these numbers here on this side of the graph because those numbers will just give us imaginary numbers, and we can't graph imaginary numbers on the coordinate plane. And so that's the parent function for square root equations. Let's take a look at the parent function for cube root equations. General equation will look something like this: y equals the cube root of x. And on our table of values, we can plug in different numbers there. Cube root of 0 is 0. Cube root of -1 is -1. Cube root of 1 is 1. Probably be better if we used maybe 8 here, because the cube root of 8 is 2. The cube root of -8 is -2. But anyway, if we graph those points on a coordinate plane, this is what we're going to get. We're going to get a point at -4, -4 and -1.59, -1, -1, 0, 0, 1, 1, 4 and 1.59. We could also have a point at -8 and -2, which would be about here somewhere. And then +8 and +2 would be off in this direction. But then if we smooth those points out, then we get a curve that looks something like this. And so notice that we can take the cube root of negative numbers. We can't take the square root of them, but we can take the cube root of them. And so those are just going to be negative numbers. The cube root of positive numbers are going to be positive numbers. So we get a parent function that looks like this. Let's move on and talk about the general equation of both of them. So we have the general equation for a square root function, which looks like this. The h and the k are going to move the graph left and right, up and down. The a is actually going to change the shape of the graph. And then the parent function for a cube root function is same letters. You're going to do the exact same thing to the graph. They're just going to change the different parent function around. And so let's start with the square root functions, which is this equation right here. We're going to see what happens when we change anything from the parent function, which is just y equals the square root of x, and start adding the h and the k and the a values. So let's see what happens first with our parent function. If we graph it, we know it looks something like this. Remember, we have the point 0, 0, 1, 1, 4, 2. We could have the point 9, 3 or 16, 4 if we went out far enough. But what happens when we add something inside the absolute value sign? Like, for example, we add square root of x plus 2 or square root of x plus 3. And what's going to happen is that it's going to take the entire graph and shift it to the left that many units. So if this was square root of x plus 3, it would actually shift it to the left 3 units. And if we added a negative number like square root of x minus h, it would actually shift things to the right the same number of units. And so the h is going to move things left and right in our equation. And then if we take a look at the k value, adding numbers outside of the square root sign, then it's either going to go up k units, or if it's positive, or it's going to go down k units if it's negative. And so the k value, just like in many of the other equations that we've done this year, is going to shift the graph up or down that many number of units. So let's see what happens here when we do the same thing with our cube root function. Remember, our cube root function, the general equation looks like this. Remember, we have a point at 0, 0, 1, 1. We can go 8, 2, or -8, -2. But when we add a number to the h value here, when we add an h value, again, just like with the square root function, it's going to move it that many units to the left. And when we have a negative h value, so it's the cube root of x minus h, it's actually going to move to the right the same number of units. So it looks something like that. If we add a number outside of the square root sign, like to the k value out here, then it's actually going to shift it up that many units. And so it would look something like this. If k is 3, it would move up 3 units. And if the k is a negative number, then it's going to be shifted down that many units. And so the h and the k in both cases just shift the graph left and right if it's the h value, up and down if it's the k value. So then what happens when we change the a value? So again, if we take the general equation and we add a number like 4 out in front of it, what's going to happen is our original equation is the blue line, and then it's just going to make everything 4 times as wide. It's like stretching it out 4 times. We still are going to have the point 0, 0, but instead of having the point 1, 1, it's going to be the point 1, 4. Normally we could go over 8 and up 2, but now we're going to go over 8 and up 8 because it's 4 times as tall as what it used to be, because that number there is a 4. And so same thing in the negative direction. Normally we go negative 8 and negative 2, but now we're going to go negative 8, negative 8. Or normally we go negative 1, negative 1. Now we're going to go negative 1, negative 4, because we're stretching it out 4 times as tall, or as stretched out away from the x-intercept or the x-axis as it was in the original parent function. And then, as you might guess, if the a value is smaller than 1, then instead of getting bigger, it's going to get smaller. Instead of going over 1 and up 1, it's going to go over 1 and up a half. Instead of going over 8 and up 1, it's going to go, or up 2, it's going to go over 8 and up half of that, which is just up 1. And then if a is a negative number like negative 1, what will happen is the entire graph will be reflected over the x-axis. And so it's going to look something like this, where we have, instead of going over 1 and up 1, we're going to go over 1 and down 1. And we get a graph that is just inverted or reflected over the x-axis because of the negative 1 value. Same thing goes with when we're describing square root functions. So let's take a look at this. See if we can describe what's going to happen to these graphs. How do we get the g of x function if we know that the f of x function started out in the parent function? Here, because of this plus 5, we know that it's going to be shifted 5 units to the left. The next equation here, if we start with this function here, but we move to this function, we know it's going to be reflected over the x-axis, and it's going to be shifted down 10 units because of the minus 10. So that's what you have here. Let's take a look at the domain and the range of these. If I have a function that looks like this, I know it's going to start at 0, negative 6. It's going to look something like this, 1, 2, 3, 4, 5, 6, and shoot off in the positive direction, which means the domain value is going to be the x values that are greater than negative 6, and the range values are going to be the y values that are greater than or equal to 0. Greater than or equal to, it should be on both of those. And then if we look at a cubic function, we know that this cubic function is going to start at positive 7, negative 4, which is in this direction. It's going to be inverted, so it's going to look something like this. But for both the domain and the range, it's going to go forever to the left and to the right, which means the x values are going to be all real numbers. And it's going to take a while, but it's going to go forever up and down, which means the y are also going to be all real numbers. The range is also all real numbers. So this is a little example of what you're going to be looking at on your homework assignment. You're going to be graphing these equations. And I would say whenever you graph a quadratic equation or a square root function, you need 3 points. And whenever you graph a cubic function, you need 5 points on the graph. And that would be the same thing on a quiz or a test. So that's what our homework assignment is like. We'll go over questions tomorrow in class.